Muscle contraction is a complex process that occurs when muscle fibers respond to stimulation, typically from nerve impulses, allowing them to shorten and generate force. Here is an overview of the physiology of muscle contraction. 1. Nerve impulse and neuromuscular junction. Motor neuron activation. A muscle contraction begins with a signal from the nervous system. A motor neuron sends an electrical signal, action potential, to the muscle fiber it innervates. Release of acetylcholine, ACH. The nerve impulse reaches the end of the motor neuron at the neuromuscular junction, where it triggers the release of the neurotransmitter acetylcholine, ACH, into the synaptic cleft. Activation of muscle fiber, ACH binds to receptors on the muscle fiber's membrane, sarcolemma, causing an influx of sodium ions, which generates an action potential in the muscle fiber. 2. Excitation contraction coupling. Action potential spread. The action potential travels along the sarcolemma and down into the muscle fiber via the transverse tubules, T-tubules. Calcium release. This action potential triggers the sarcoplasmic reticulum, a specialized organelle in muscle cells, to release calcium ions, Ca superscript 2, into the cytoplasm of the muscle fiber, calcium binding to troponin. The released Ca superscript 2 binds to troponin, a protein that, along with tropomyosin, helps regulate muscle contraction. Crossbridge cycling and contraction. Exposure of binding sites. Calcium binding to troponin causes a conformational change that moves tropomyosin away from actin's binding sites, allowing the myosin heads to attach to actin. Formation of crossbridges. Myosin heads bind to exposed active sites on actin filaments, forming crossbridges. Power stroke. Using energy from ATP, the myosin heads pivot, pulling the actin filaments toward the center of the sarcomere, the basic contractile unit of muscle. This sliding of actin past myosin shortens the muscle fiber, producing contraction, detachment, and recocking. Another ATP molecule binds to myosin, causing the myosin head to detach from actin. The ATP is hydrolyzed to recock the myosin head, readying it for the next cycle of attachment, pulling, and detachment.